Hello everyone, welcome back to What's Inside of Season 3. This is Episode 3, where we're going to be going over this stepper motor. This thing is really cool, really fascinating, because, you know what? It's about precision. This motor moves in precise steps. It's perfect for things that require super precise movements over and over and over again. And as well as this chip, which you can see, this motor plugs in and out of it. This chip is also super cool. It's fascinating because of the electrical currents it can send to the motor. And William can just give you a brief overview about the resistors and the LEDs on this chip.
Yeah, so these resistors will ultimately, and some of the other components will help you to regulate the electrical current flow. And some of these LEDs, so they receive some of these signals from these components and ultimately sending the information to the IC, which will ultimately help to light up the LEDs. And what it does as well is that it takes some of the electrical signals from the computer, from the code, and ultimately it turns them into mechanical actions, such as powering this motor.
And you know what's really cool? Colors. There's so many different colors of wires. Blue, pink, red, orange, and yellow. Wow. Let's get into the analysis.
So, hey everyone, welcome to a quick rundown or quick analysis of the stepper motor and the ULN 2003. So, why do stepper motors actually matter? When you need precise, repeatable mechanical motion, these DIC motors just won't cut it. And you need to position without feedback, open loop control, fine angular resolution, bidirectional motion, holding torque at zero speed, digital control via microcontroller. Just a few examples. And this is exactly what the stepper motor delivers. It moves in discrete steps, which are perfect for robotics, plotters, and actuators.
Now, what is the 28BYJ48? This specific motor, the 28BYJ48, is a 5-volt unipolar stepper motor with 64 steps/revs on internal rotor, a 1/64th reduction gearbox, and the total amounts to 4,096 steps per rev, which is about 0.088 degrees per step, which means it's super precise. We'll talk more about that later. It operates from 5 volts and is driven via the ULN 2003 Darlington array. And the 5-wire interface includes 4 coil wires and 1 common. Now let's get into the subsystems, such as the stepper motor intervals, which William can tell you about.
So what the piece or the motor that Josh just explained, it contains the stator, which are 4 electromagnets or coils arranged around in the inside, the rotor, which is the permanent magnet gear with teeth, internal gearing, plastic reduction gear, train 1/64. So when the coils are energized in a sequence, the magnetic field rotates the rotor in small steps. Each full rotation of the rotor, which is 64 steps, turns the output shaft only 1/64th of a full turn due to gearing. This means that there's a total of 4,096 steps per revolution. And all in all, this gearing increases the torque and improves positioning resolution at the cost of speed.
Now let's get into the motor wiring and phases. So let's see the colors that I was mentioning earlier. So there's red, which is the common V+. There's blue, which is coil A, pink, which is coil B, yellow, which is coil C, and orange, which is coil D. This motor is unipolar, where current always flows into the coils from the common line. This simplifies drive circuitry, which means that there is no H-bridge needed. And basically, the sequence which they flow through determines the direction. if it goes from A, B, C, D, that is blue, pink, yellow, orange, it is clockwise. And if it goes from D, C, B, A, it turns counterclockwise. Now let's get into the ULN 2003 driver IC.
So this piece right here is the driver IC, and what it includes is the ULN 2003, which is a 7-channel Darlington transistor array. And it inputs IN1 through IN4, which are connected to the Arduino digital pins, and it outputs out 1 to 4 wired to stepper coils, flyback diodes for inductive kickback protection, and finally LED indicators, which show the active channels. And each input from the MCU switches a high current, high voltage path through the ULN 2003, energizing the coil safely. This is because it's a Darlington pair, 2 BJTs per channel. The IC can handle up to 500 per mA per channel, 50 volts inductive loads, TTL/CMOS logic levels.
And as always, there are a bunch of more things that we can cover, such as the stepping models, the gear reduction system in the motor, the timing and control from the Arduino, as well as the limitations of physical design and the troubleshooting behind it, as well as the practical applications. But there's just too much to cover, or else we would be talking here for hours. So yeah, now you know with this motor, this little board does. Plug it in, and a lot of magic can happen. So as always, remember to stay curious, because that's what's inside. Until next time, I'll see you then.